Hello, Jason. Audio check.
Your audio is working. Is mine okay?
Yeah, great. Thanks.
Good morning.
Good morning. Good morning.
Morning. All right. Just checking that people can hear me. A few minutes to get ready here. Give people probably another minute or two to join. All right. Are you able to see my presentation?
Yes, it's visible.
Excellent. All right. Let's give people maybe one more minute and then we get rolling. I see we still have participants coming in. All right. So 5 minutes past the hour, so I'm just going to open the meeting here. So let me go to my first slide. So here's kind of my proposed agenda for today. So we start with some level of well, we're saying welcome. Well, welcome to this work stream. I'm really excited that we got this off the ground and, are very hopeful and motivated to, produce something here that's going to make all our lives, easier down the road. So that's my Debug, the welcome part. I was thinking we spend some time on introductions. Always we have to do a poll for a new meeting time, and then I wanted to review the charter and get kind of in an open discussion on what our goals are and have some discussion about an agenda outlook. All right, go one more slide. So as far as the let's say the logistics here, I kind of put the the important links here. So we have a wiki that has that's where I'm going to post the recordings. That's where we're going to post minutes and any important documents. What's there today is essentially our charter and the kind of administration. level information I have here. We got the links for the email group. I am assuming you're all already subscribed. If not, I want to definitely encourage you to do so. That's where kind of all the offline discussion is going to happen. There's a link to subscribe to the calendar, so you're up to date and getting the calendar invites. Again, since you're here, you probably have done that already. And you have any additional questions and suggestions, just you can always reach out to me directly. That's my email. With that, I want to get into introduction. So I'm the easiest person to start with is obviously myself. So my name is Marco Baccia. I work at Intel as a principal engineer, focusing on system management, architecture, primarily for our AI products, but also involved in the other aspects. I've been doing that for, oh my God, around 3.5 years now. Before that, I had a long career doing all kinds of things. I sometimes joke that I'm like running low on the things I've never done. So, yeah, so that's me. Enrico, you want to go next?
Sure, I can go. My name is Enrico Carreri. I am a senior principal engineer, chief debug, DFD architect for Intel Corporation. I've been there 26, 27 years. I'm also, in my other life, I'm also the MIPI Alliance Debug Workgroup Chair and for that industry group and its specifications. Thanks.
I'm just going to keep calling people out. John?
John Leon, Intel. I am the OCP steering committee rep for hardware management project. So I oversee all the projects under, and I work directly with the project leads to provide logistical support if needed.
Hey, John, maybe we add this. So, where are you located?
Where am I located?
Yeah.
I'm located on the coast of Washington State. I work out of the Hillsborough campus.
Okay, yeah. So I'm also working out of the Hillsborough campus, and I'm located in Hillsborough.
I'm out of the Intel's Folsom campus, which is right outside of Sacramento in California.
All right. Jason, you want to go next?
Sure, just making sure I'm the only Jason. So hi, my name is Jason Peck. I work at NVIDIA as a debug architect for the Tegra SoC division. So I've been at NVIDIA for a little over a year, but I've been in the industry working debug architecture for approximately 25, 26 years. You know, I know Enrico from MIPI. I'm the vice chair of the debug working group. And what else? I'm based out of Austin.
Awesome. Peter.
I work for AMD as the data center GPU or machine instinct debug architect, as well as I do out-of-band RAS. I'm part of the GPU RAS OCP workstream, and excited to hear about and talk about debug. I live in Houston, so I commute to Austin every once in a while.
And Jeff, you are the last person that I see. Definitely not least.
Yeah, Jeff Kennedy, Dell Technologies, ISG CTO, so solution strategy. One of my focus areas is the management plane in the box.
Excellent.
Marco, there's a couple others. I don't know if you see them in the participants list.
I don't.
Yeah,
Yeah,
I'm Brent.
Marco, I think you missed me probably because I joined late.
Yeah. Okay. I only don't see everybody. I don't know why. Anyway, okay.
Hi, I'm Brent Byron from Micron. I work in SSD. I have a focus on error management from that perspective. And I'm in Boise, Idaho.
Excellent. Justin.
Hi, I'm Justin King. I work for AMD. Been here a little over a year and a half now. I work primarily in the area of systems management and telemetry, interacting a lot with our debug architects like Peter. And I'm in all sorts of OCP, DMTF, UA-Link work streams. So see several names that I recognize on here.
All right. Did I miss anybody? So I don't use Teams enough, Zoom enough. Okay, I don't see anybody, no matter how far it's remote. Okay, awesomeness. The next point I had on the agenda is kind of running a poll for what's a good meeting time. I kind of picked this one, based on the availability of everybody that was on the work scene at the time. It was just me. So, John, do we have a good mechanism to run these polls in OCP?
Oh, I usually use a doodle poll, which is a free meeting coordination site.
Okay, but which so okay, I want to just actually hear some suggestions. What works for those who are the others on the call. This is actually not necessarily the ideal time for me either, so I was just trying to pick something that's moderately convenient around the globe. But I see that everybody on the bridge is actually in the US, so maybe a later time would be good. But yeah, well, I'm open for some suggestions.
Okay, so 9 o'clock won't work for me on this day. It's followed by another standard spot meeting I have to get to.
Also, you threaded the needle really well for me. Thank you. This is a good time. Anything else is problematic.
Yeah, Marco, you actually somehow found a good time for me.
Magically.
Well, this time overlaps with the Redfish Forum meeting. So I represent Intel at both the DMTF and OCP. And UEC for that matter. So I'm constantly in conflict with other meetings. So as long as I'm not necessary, I'm fine with whatever meeting time you guys pick.
Okay, well then, I mean, I'm gonna definitely still put up a doodle poll for suggestions, but I mean, anybody that's here right now that has that this time isn't good.
Yeah, this isn't a great time for me. I could potentially work with Peter and I don't think Nitish is on the call to see if they can cover. But
okay.
For me personally, I have two standing conflicts. So
okay, is there a time later in the day or on a different day that works better for you?
Thursdays are generally just bad for me. And Marco, you and I are on 3 meetings together on Thursdays now. So
yeah, I know. It's slightly crazy. And we work for competitors.
Yeah.
Yeah.
So Marco, if you haven't used a doodle poll, you basically pick up 10 times through the week and have everyone vote on which time works for them.
Okay, I'll go do that.
And then that way you can just say, hey, the majority says this is good for them.
Yeah, I'll do that. Okay. Yeah, so I put out a doodle poll. I mean, if you want me to do me a favor and kind of
I'll give you the pointers.
Send me some block dates for if you have them, that'd be great.
The poll will allow you to pick like, okay, these are great, these are okay, and these are no.
Get out of here. Yeah, okay.
Yeah, cool. I can't do. I can't. This is a hard. Yeah. So the polls, I've done the poll many times. It's a good tool.
Okay, I'll figure that out. I'll get with John how to do that. Awesomeness. Let's get to the next.
Sorry, Marco. From the people that have, I guess, joined the work group, are you able to tell like what part of the world people are in? Is it primarily U.S. or?
Yeah, I mean, everybody that's like physically here seems to be in the U.S. I haven't Yeah, I mean, I can take the AR of looking at the at everybody that subscribes, that joined the subscribe to the OCP group, to have a guess where they are. But yeah, I mean, so clearly everybody that's here right now is in the US.
Right.
So that's why I'm kind of, I don't know how it is for you guys, but my mornings, my calendar lightens up as the day goes on. Let's put it that way.
Mine's the opposite, but I like this time slot. Just for the record, I'm fine with this one.
Okay. Look for the doodle poll. Excellent. Let's move on from that. So the thing I wanted to do was now is kind of review the workstream charter, and then also have a maybe a lively discussion on what we're trying to accomplish, what we need to accomplish first, and so on. So yeah, so I pulled up the charter. I'm assuming you all read it, but it is really I'm not gonna read it here, but I'm going to kind of tell you maybe the history from where we started. It was Enrico probably like half a year ago, right? So maybe half a year ago or
Something like that. 6-9 months ago, we were.
6-9 months ago, I was presenting somewhere and made a statement. So we don't have a standardized way to debug what we call debugging at scale, meaning to debug remotely in a data center, and hence for some of our products that maybe follow like a PCI card form factor where we don't really know what system they end up with, we kind of see significant limitations to do what we feel we need to be doing. And then Enrico was just saying really bluntly, well, why don't you fix that? or why don't we fix that? And this is essentially the outcomes of why don't we fix that? And it's really the idea is to create an architecture standard that describes the interfaces, protocols, and APIs, sort of data models that let us communicate debug information between our devices and debug host, be it locally attached or be it attached remotely over management network, most likely. And so that then in the future we have a system where we live in a world where you can let's say Dell can easily build a system that has AMD and Intel and NVIDIA components in them, and debug them in a coherent way without making investments 3 times because there's 3 different silicon vendors involved. So that's essentially the basic idea. I'm going to kind of leave the stop right here and maybe start some discussion and feedback.
Mark, do you have a link to the charter diagram, and do you think it's worth showing that?
Do I have the link?
If not, I can put it in the chat.
Yeah, why don't you still share it real quick, and then
okay, first I'll put it in the chat.
We'll put it in the chat, yeah.
Okay, it's actually part of the hardware management project wiki, and so I've added that link for those who want to see it.
Let me share it.
So do you want me to share? Oh,
yeah. I was sharing only my PowerPoint, so that's why.
Oh, okay.
That was a bit more complicated then. Oh, you're sharing now.
Okay, do you see this?
I see your chat.
Someone said yes.
There you go. Yeah. Now we can see it.
Okay, so this is a I call it charter diagram for the entire hardware management project, and these are represent all the sub projects and the work streams that exist within them. I'm not going to go through it in detail. I will highlight that these two interfaces are the manageability interfaces. This is Redfish manageability at the platform level and below, and above that is a rack management interface, also defined in Redfish, that can be used to manage platforms, which also expose the Redfish interface. So within here, there are a bunch of working groups that we know are closed, but they have a certain charter. We kind of put their placement so we know where they're working. Both of these have a hyperscale GPU and hyperscale CPU have released documentation, but their limitation is that they only go up to the Redfish interface exposed by the platform. That's fine. That's their bailiwick. This is where Michael has placed DC Diag and Debug, which is up here above this layer. So it's supposed to go manage platforms within the data center, which hopefully are exposing the Redfish interface. Get a good summary, Michael?
Yeah.
Okay. So one of the questions we have on the fly, which I told Michael when he came to me with this idea, I said, you should really put this thing in here. So that's an ongoing discussion as to whether it should exist outside fault management or within fault management, because within fault management, their main goal is getting all this data off the platform onto something external to a platform which can actually cogitate on it, whether it's to find fault or whether it goes a step further to actually attempt to do diagnostic and debug on the data that it gets. So I told him that you should just use the same framework because fault management has been ongoing for 2-3 years now. So, any questions? Okay, that's all I have. Back to you.
All right. Let's not share again. Okay, how do I see what I'm? Can you see my screen, my slide again?
Yeah.
Okay. So, any questions or comments on the charter as we have outlined it, or suggestions for refinement? Take silence as agreement. Okay,
So I guess one question is, what do you hope to produce?
So what I yeah, that's actually a good one. Yeah, so what we hope to produce, right, is a set of specifications that define the interfaces and protocols and APIs at various touch points. And one of the first topics of the work group actually in my agenda outlook would be really to go look at the system topology and agree what those touch points are and where we want to have standardized definition. And then we can't work on everything at once, so we'll have to at least establish an order. And let me quickly show a slide that actually does this go there? Why not? Let's see, why does it not want the slide? Let's jump, see if I can get to it. That was, are you probably not showing anything anymore? Great. 1 second.
I guess a question I would have is, how are we going to ensure we have good interlock with some of the activities that may be happening in I guess a struggle too might be some CLA-based work streams that might be making progress here and there. We really can't interlock as well. Is there kind of a game plan for how we don't like step on toes and stuff? I'm just reading up OBMF work stream, like the Open Boot Management Framework, which speaks to boot configuration, runtime communication between host processor.
Mhm.
So just making sure we, excuse me, just have a game plan for that we don't charge parallelly into the night and find ourselves intermixed.
And yeah, no, that's actually a really good comment. John, do you have a good answer for that?
Yeah, I mean that's probably one of the reasons that we have I've showed you the charter diagram, is that the idea was the charter diagram was created when work streams are known, so that we can construct work streams that do not have charter conflicts. Because if we don't resolve the charter conflicts, then later on we're going to have documentation conflicts where both sides have generated documentation that they believe within the charter, and they may or may not be interlocked or complementary to each other. And so that's why there's a lot of effort right now to make sure that charter diagram is correct. With the location of DC Diag and Debug, I told Michael, where do you believe you set? And I've asked the closed work streams to verify their location on the charter. And so currently I've gotten feedback from like one person from the hyperscale CPU workstream regarding where it is located. And I've asked him to, one, verify that with the rest of the workstream, uh, provide feedback on whether putting DC Diag and Debug into fault management would alleviate the concerns of charter conflict and hence documentation conflict. And third, if they have feedback on the charter that wording changes that would help alleviate their concerns. So that's one reason why I showed the charter diagram. If we get that right, then we should have no charter conflicts in the future. Second is it also shows the rally behind on both sides of the Redfish interface. And I'm hoping the Redfish interface becomes the separation point between where one effort workstream ends and another workstream begins. So if the hyperscale management work streams end at this is the Redfish interface that we want to expose, that the DC Diag would complement that, as they're not going to tell you into tell you what the GPU and CPU are. They're going to look at more generic Redfish requirements of systems that are part of the DC diagnostic framework. Does that answer your question?
Mostly, yeah.
Okay.
Sounds like we need you to we rope you in when we feel we're getting off course or something like that.
Definitely. I mean, my concern, and I've told the project leads, is that if you don't fix it early, you're going to fix it at the end. It's going to be far more painful at the end, trying to resolve work that people have already put a lot of energy believing that was within the charter.
Got it. Thanks.
Yeah, and I mean, definitely have some interesting artifacts of that already, right? Like we assigned the AMC acronym twice for two management controllers that are not the same but very close together. So just pick on one thing. All right, let me kind of share this slide now. Sorry, it's gotta get a little complicated because it was originally hidden in my presentation because I wanted to get. So what I have here is, and please confirm that you can see my screen again, is what I would call my like visionary desired end state, yeah, topology, right? So we have you know, we have a data center that's obviously full of nodes that are full of equipment, and they're all very diverse. Basically, the way I've drawn this very colorful diagram, I've got like, an example of 5 different hardware vendors that provide ingredients. And in this imaginary data center, the various nodes are constructed of a very colorful mix of ingredients from different people. They could be like what I have here, something where I'm showing GPUs and the CPU that are relatively closely integrated. That provides challenges and opportunities to optimize. Then we have other components that come in for an what do I call this? An open, interchangeable, interoperable interface like a CAM card, like an EDSFF module, right? Where you, at the time this part of the server got constructed. We don't necessarily know what NICs are going to end up in here. Other servers might be, exclusively constructed of these plugin cards, and so on. And the way I see this from a vision point of view is that I want to be able to both what we call debug at scale or remote debug, as well as what's important to us is the idea of a closed chassis debug, meaning you have a connector on the outside of the box that you can arguably attach a laptop to. That in both of these places we have kind of universal debug and triage tools that can interact with any of these components in the data center in a uniform way, and then would provide probably some kind of a plugin interface to a vendor specific component to to interact with the component directly, or probably primarily make sense out of the data that comes out of it. So for example, let's say you and because let's pick on like let's say we have a debug use case where you pull a ginormous register dump out of a CPU or a GPU. The methodology to get that couple hundred megabytes of registers out of the device, and getting it into this tool is the thing I would like to see standardized. But we wouldn't, like, there would be not really also no physical way that we, AMD, NVIDIA, and Intel agree on, what's in the register file. That makes no sense whatsoever. That's all highly proprietary information, right? So the idea is that then, that the files from the outside to this tool look all the same, but that would interact with a plugin of some sort to basically make sense of the data. And then the same or very similar tool would be running in the closed chassis debug environment. Questions and comments on this picture? Does anybody disagree with what I'm showing?
Marco, you have USB for the sort of local debug laptop.
Mm-hmm.
That wouldn't surprise me as to where we would naturally end up anyway, but is there a reason you've picked that?
Yeah, I've tried to kind of walk kind of, strike a balance between not prescribing things, but then in places where I believe that, where I strongly believe that there's really only one option, right? That's where I'm kind of saying I'm gonna call the things what they are, right?
Yeah, but I think, Marco, when we looked at
Yeah.
this too, I mean, let's be honest, we don't want to we want to keep the cost of all this low, right? As low as we can. So if you're going to connect up, let's say, that debug laptop, what interfaces does a laptop have natively? Right? USB is it, right? Because what you really
that's exactly my point, right? Like this is, to me, the only interface into a normalish laptop, right, is a USB port.
Yeah, you don't want a laptop in a box and this and that and a special cable. You don't want it. Nobody wants that, right? So I think that's one of the reasons. And we could probably debate up and down. Well, okay, what does USB mean? Is that USB 2? Is that USB 3? We could debate that, whatever. And that'll be the fun of the work group. But it's really just, let's try to keep the cost low. What's native to a laptop or a PC or whatever? It's probably USB.
Yeah.
I mean,
Okay.
Yeah.
So that was driven more by the what's available on a laptop rather than what's available in a true data center component. Okay.
Exactly.
For that side of the interface, yeah, that's what I would say. The other side of the interface is that's a whole different story, right?
Right.
Exactly. That's exactly the logic between the two things I call out, right? The USB ports is the only thing that's practically coming out of a laptop.
But
right?
the trick of all this is going to be, when I look down that USB pipe, and in this case, when I look down that Ethernet pipe, what is kind of shown here, but I'll say it strictly, is when you look down those pipes, it better be the same stuff, right? Because that management server and that red box and the red box and the laptop, you want that the same.
Yeah.
Right. And so that'll be kind of the trick to all this is, okay, we know USB and Ethernet are different, but can we make it such that, well, maybe that's just a transport thing, right? And maybe one's a little faster, one's a little slower. You can argue all that. But from a protocol extraction, API, that's what I think one of the goals we want to do is make that look the same. And then hopefully, as things progress in the future, if that Ethernet changes to something else, if that USB changes to something else, well, hopefully, if we do this correctly, that won't be a big deal, right? I think that's what those are kind of the idealistic visions, right? That I think we want, that we have here.
Yeah, absolutely right. I mean, of course, my first underlying require, and then should you go back to Justin? Right? The same approach I've kind of taken here, right? Like if you want to, remotely connect to something in a data center, you're going over the out-of-band Ethernet network. I don't see us doing this any other way. Yeah, I mean, but and then the trick is really that, whatever gets presented here, right, is presented in a way that, this universal tool can, enumerate / discover, and know what the various objects are and how to handle them, right? And the same kind of happens up here.
And what's not shown here, I think, it was shown in the earlier slides of this original deck, was, the whole point is you want to be able to do all this debug. Doesn't matter what interface you come into, because, I mean, in some ways you may be dictated which interface, but based on where you are in your life cycle, right? Or how easy it is, right? If I'm just doing a single node and I have the ability to crack it open or touch it, maybe USB is just a lot easier, right?
Well, I mean, if you can physically get to it, right? I'm like, I mean, you and me just, yeah, I mean, you and me, we looked at, I mean, even if you, like, quote unquote, like the closed chassis is like if you can physically get to the box, right? Which is like whether because cracking it open is depending on what the system is also a whole another
maybe good luck with that.
Good luck with that, right? Like I mean, I can't get. Yeah, I mean, remember we looked. So I have a fixture that I unfortunately can't share of one of our open chassis debug setups for one of our AI nodes, and it's the size of a small car. It's completely.
But I think too,
unwieldy written all over it, right?
Yeah, but I think too, what I'll say is, I mean, at least from my perspective, I'll put my Intel hat, right? If it's USB or something else, let's debate that, right? If there's something better, but I guess for me, it's just I want to keep this as simple, as low cost, right? But as effective as I can make it, right? So I think, Mark, you probably put these here as discussion items, maybe things that are maybe an obvious solution, but maybe there's a not so obvious solution that's better, right? So
yeah, exactly. Like these two felt to me like the obvious candidates, right?
Yeah.
And if you're, somebody, one of us believes that I'm wrong, let's have the debate.
Yeah.
I am.
Well, but
I'm
Enrico
happy to
brought
be
up
wrong, right?
Yeah, sorry, Enrico brought up a good point, right? I mean, he mentioned the life cycle. It depends on the life cycle that you're sort of in at the time that you're to use this tool, and that whether you could crack it open or not. And certainly in certain life cycles, you won't be able to crack it open, but you would be able to, if you were, sort of early on in the development, or if you, pulled the machine out for closer analysis. Outside, not running like real workloads, for example. But I imagine, I mean, this whole discussion needs to be this. I mean, we have to have that discussion in the context of that full life cycle. And I think you even had a bullet on that on the charter page. And I imagine even some of these boxes or these plugins may not be allowed during certain life cycle states, right? And so I think we have to always think of this in terms of that life cycle. So I don't know if we need to talk about what the life cycle is first, or
I think that's another valid discussion we can have. And
I know we had a proposal when we were pitching.
Yeah, we have a slide for that. So
yeah, but I think it's important, because I think it's also important to know the limitations, right?
Exactly.
What our expectations are. We probably all know what our things are, but we probably have different names and things that we want to kind of normalize on, because I think that's also going to be some interesting pieces of where aspects of things like security, bandwidth, availability come into play, right? And it goes back.
I totally agree. I think the life cycle and the scope, our scope inside the life cycle. I'm going to put that probably really on the agenda for next week, right? Because it's super important. One thing I want to say is like, I don't know. So I got this 80-20 rule, right? I think it's more of a thing that comes out of manufacturing improvements, but the logic of it is, every like process improvement, right, follows usually a curve that is like shaped like 1 minus 1 over x. And I don't have a slide for it on hand, but maybe you can imagine in your head what that looks like, right? It starts very steep, and then as you get to the end, you put more and more effort into it, and you never quite reach your goal, right? That's kind of that. Actually, maybe I can use my mouse. It's basically kind of a trajectory that's like that. And what I believe out of that is, when you're driving improvements, it's like anyway, on this curve that I'm virtually drawing here, there's this point there. It's about 20% of the effort gets you 80% of the benefit, and like I believe that's a really good place to aim for, right? And leaves the things that make this, terribly complicated maybe for later. Like maybe, yeah. Does it make sense? Excellent. Let's see. Actually, what just happened? Okay. Talking of life cycle. And because I think that's the picture you were talking about, right?
No, I guess, I mean, this was trying to show all the different pieces, right? I mean, this was something we proposed, and of the different of the life cycle, and we put it in here just to really kind of show how, as you go from left to right, things, obviously things change. You go from, as it says here, representative workloads to real workloads, and we know that the availability of things change as you go. And I think we have to find a way to, again, this is from our perspective using our terminology, but I assume others have maybe some slightly different terms that they use, and we'll just need to normalize that and make sure that we all have a common set for this discussion. But I think for me, I think when we looked at going back to the USB and Ethernet, I think the important thing is we have an underlying set of debug that's in the silicon, right? When we look at it at the platform and at that scale piece, that's where, as you move through the life cycle, we have to have a scalable solution that allows through different interfaces, different bandwidths, and so on and so forth, right? And I think that's where this tie-in comes into play, and where it's going to be the fun of this work group is to find how to keep that balance of making sure that we get what we need in each of these things, but make it scalable so that each of these states aren't different solutions, right? That would be the worst case scenario, right? The best case is you having scalable interfaces, as an example, having scalable interfaces so that I can minimize on the tooling and software aspects.
Yeah, I think tooling is the magic word here, right? Like I don't want to I'd like to not have different tooling over here and over here, right?
Yeah, I mean, you may have different layers, like you're going to need a USB driver versus an Ethernet driver, but the rest of the stacks, right, is what you want to keep, right?
Exactly, and to go back to comment was made earlier about what's allowed, right? The enabled capabilities might be also different, right? Like there's probably low level intrusive debug that we allow over here that we won't be allowing over here, right? Well, it also doesn't make any sense, right? To pick on.
I guess I'll go partially deeper. I'll say that that there's a line even further left and whatnot, and we could all talk about that in our own respective vendor companies. But I think the expectation here is that there's a low barrier to adoption of this for not just the customer, the end user, because that's the only way they're going to give us this as a vendor, the information, is if it's hits all the pieces of security and etc. But also, if we end up not being able to use this internally for each vendor for our own purposes, it continues to be probably a disparate. It tends to potentially be a disconnect. We won't be able to solve that in here. Like we won't be able to talk about that in all the details, but just pointing out that sounds like a little bit of what you're saying.
I would totally agree with you. I would say it's actually a bad thing if that's the case, right? If you're our internal, if the vendor like ourselves, right, that we're using a different infrastructure than the rest of this, that's pretty much a non-starter, right? Yeah, at least in my mind, I mean, that's how at least I want to. Again, I'm going to be selfish. What I would want for my company is I I don't want that, right? I'm going to
Yeah.
come in with that attitude at least here.
Yeah, no,
I'll be
it's the same company, but yeah, I mean because yeah, I mean because at least the problem we've seen is when they're not connected, right, is that you know these tools evolve and mature maybe even on a given product as we develop it, because we learn, right, especially if you have something that's groundbreaking and new. So these things evolve and evolve, and because they're different from over here, this kind of gets left behind, and then has, doesn't have the evolve the capability necessarily the capabilities that got evolved over here, right, to pick on something.
But yeah, Peter, I mean, I would say, I mean, to me, it's that is definitely a consideration in my mind when we're talking about this is, when we're creating the scalability. Yeah, you're right. There are like a couple more boxes to the left that I'm going to care about and make sure that my team, my guys, the people that are in the lab trying to get this thing out the door, to our customers. Yeah, I'm going to make sure that I can scale even further. So I'll be upfront. Yeah, that's going to be a consideration, at least for me in these discussions.
So Enrico, I think you described this as a proposed, I guess, flow. Does OCP have a sort of have they already defined the life cycle of a data center somewhere, just as a reference point, or is that something we're going to have to do here in order to have that discussion?
I was not aware one. I know when Marco, when you and I, when we put this slide together for this work group, we weren't aware of any. That doesn't mean that there isn't one, but I don't. We weren't aware of any.
Okay.
Yeah, we want to. John, are you aware of anything like this?
This is John. So no one does not exist. There's this box in the charter diagram right next to DC Diag called Scalable Infrastructure Management, and they have charted to do lifecycle, which they have not produced anything.
Okay, just in the spirit of not stepping on anyone's toes, which is I think was what John was talking about earlier. But
is that an action that we should take? Is to kind of share with them at least, hey, we need this, and we have some ideas, and maybe we can partner with them or something. Is that something we should think about?
That would help, because a lot of their issues that they've been without direction, and so recently, within the last couple of months, they've set a direction on telemetry. And so they're currently penning that white paper. So they had 3 white papers. One of them was lifecycle, one was telemetry, one was something else. And I said, get one of these contributed and released, guys. We're gonna fold you guys up. So they picked, and they said telemetry. So knowing that the product would actually be consumed or useful to another work stream would be useful for the direction.
So Marco, we should take that action item, and we could share with them what we have, and like I said, what we're desiring.
Yeah, absolutely. John, can you IM me, text me where's the lead there? I guess I can also get it from the OCP.
Yeah,
website.
I can.
Okay, awesome. All right.
Good suggestion, Jason.
Okay, let me see. Okay, maybe I want to actually get into.
Yeah, you got just a 5-minute warning.
Yeah, I know. What's happening here? Yeah, so I'm gonna maybe actually jump to this slide, which is the similar to my super colorful slide, just a little bit more, slightly more detailed version. And here's kind of where I've been, this is again, kind of zooming in, just showing, one rack, one node, one set of components. And here I kind of wanted to have, and maybe this is even, I think this is also the second, maybe this is again next week's or the weeks after discussion. But really kind of zoom in, like where are the touch points that can be, that are worthwhile standardizing, right? And like the way I see it is the most important to me. The most important ones are basically kind of going into the node, right, from the management port, and again, Justin, we can probably discuss the Redfish here. But my first view was like, yeah, Redfish is how a BMC talks to the outside world. That's probably a really good starting point. Yes, the most important ones to me are the Ethernet interface here, as well as what's happening on this USB link to the called local debug host. And then and the other ones that actually would be interesting is to see what we do about it's called the BMC southbound interface into that then goes towards the various components that need debug. Today I'm kind of showing this converter box here. Not well, I think it will be subject and outcome of our discussion here, whether what that is and if it has to exist in all cases. Yeah. Any comments on this picture?
You don't mention security.
I don't
Which
make
seems like the wrench we always get whenever we start getting really advanced in these conversations.
Yeah, no, it's absolutely, you're absolutely right. At least not, I don't mention on the slide. Okay, we got 2 minutes left. Let me just go back to my beginning here. So, kind of want to go into spend last 2 minutes on the agenda outlook. So, we want to for next week. I think we're going to review the. I want to have first the life cycle discussion and kind of have a discussion on what scope of the life cycle we believe we want to cover, as well as maybe what part we want to cover first, and then I want us to jump into the system topologies, which is kind of the slide I just showed, and have a deeper discussion there. But the other things currently I'm one of the co-leads. We have to identify and pick a second one. The way my proposal was, the way to go about this, let's have this workstream for a couple of months, and then it's probably going to emerge who are the most active people, and then we can have a ballot out to have a official selection. Justin, how long did you hold off for that on UAL? I don't remember. It was a couple of months, right?
I officially had one at the very beginning, but I did a lot of the initial work, so I think that's fine.
Okay, perfect. All right, yeah, right at the top of the hour. I'll actually, yeah. Quick question. Who is available next week? If we're assuming we're keeping this time slot. I know it's a day. It's the day before the board.
AMD has the day off next week.
I don't know if you're gonna get many people next week.
Yeah, so I may cancel next week. Probably gonna be very light attendance. Okay, awesomeness. I wish you all a good day, and we talk after the 4th. Thank you.
All right,
Thanks, Marco.